Uh, Hi, in this video we are going to see the mechanical actuation system. The components we are going to see is are the gears, gear trains and ratchet pawl mechanisms. So in mechatronics, the mechanical portion is very important over for the output what we require. So the design of mechanical in that movement of transferring the movement from one motion to another motion, some linkages we are using on either linkages or cams or gears like that. So gears, now we are going to see in this video what is a gear and how it is functioning. It's a the power transmission as a movement of energy from one place to another place. So normally we can use gears or belt drives for the transmission of rotary motion from one location to another location. Okay, the same rotation movement I am transmitting from one place to another place. How it is possible? So a gear is a component within a transmission device that transmit the rotational force to another gear or another device. So and moreover the distance is also is matter. We will see in the next slides how, where, what type of gears and what type of positions. For that it will be useful. So there are motion between the shafts. Okay, when there is a parallel shaft, a shaft where the rpm is that is the motor is connected and it is rotating with some rpm, that shaft is that speed or rotation is to be transferred to another parallel shaft. Means I have to use a spur gear or I can use a helical gear like that. So according to the position of the axis we can select spur gear, helical gear or rack and pinion methods. And position of the axis may be a parallel axis or perpendicular, that is the intersection axis. So their bevel gear also can be used for this intersection axis. Okay, non-intersecting or non-parallel, then we can use worm and worm gears like type of gears. So here let me see a spur gear. A spur gear is a teeth parallel to the axis of the teeth, or engraved here in this parallel to the axis. So these teeth are parallel to the axis and it transmit power from one shaft to the another parallel shaft. So that when get engages, when the two gear get engages or meshed with each other, the parallel one rotation is causes another shaft to rotate, another gear to rotate. So that contact is taking place with the help of the teeth, meshing of the teeth over here. So there are different type of gears over there. We can see some types of gears over here. One is spur gear, when these teeth are parallel to the axis of the gear, so shaft. Okay, and helical, somewhat inclination angle, the teeth are getting inclined angle over there, so that the contact from another gear will be more in it will helpful for making a more torque. Okay, for where there is more torque is needed, we can use this helical type of gear. And moreover double helical in both the sides. If the helical is there, then it is called herringbone helical gear. Just like bevel gears, it will help for making the rotation of the movement in a perpendicular axis. When there is 90-degree shaft horizontal, if I want to transfer the rotary motion of a shaft to a perpendicular another axis shaft, then I am going to use this spiral gear. Okay, spiral that bevel gears. So here straight and bevel gear, spiral bevel gear, there are helical, according to the teeth the gears functions or force we can decide. And worm and worm gear were in a steering system, we can see. And these are all the gears speeds can be controlled with the design of that is the size of the shafts, size of the gears. And a gear train is the one which is having two or three combined gears in a series. So it's a series of gear wheels there is called gear trains. So what we will get is the A is the driver and the last C is the driven. But normally in case of gears, when A is rotating clockwise, the B is rotating counterclockwise. And if you need the same output, the same direction, we can put an idle gear. So the idle gear will help you for making this same rotation. But if you see the gear angular velocity, omega a by omega c, that's the angular driver by driven, which is equal to the omega a by b and b by c. So b will be getting cancelled, obviously you will get it. So the idler gear is just for changing the direction of rotation. It won't make an effort in that the direction of this the thing, what is it, velocity is over there. It just changes the direction of this. And a gear train may consist of different type of gears, just like spur gear, bevel gears, and all. So the gear train is a combination of gears, which is the toothed wheels, combination of toothed wheels, we call it as gear train. And in this, the gear train, we are having different types of gear trains. You can see simple gear train and compound gear train. The simple gear train is a series of gears is connected parallelly one by one, intermeshed gears. And compound gear is two shafts, different gears, two central gears revolve together at the same speed in the same shaft. This is called a compound gear, where in the automation field, the gear shifting for the four wheelers, we are using this for changing the speed of the gears. So first gear to second, second to third, and all, it depends upon the gear teeth and the combination of the gears. We can get a different speeds. So for changing the speed to getting a different variety of speeds, we are going to have different gear trains. So in this simple gear train, a compound gear train, epicyclic and reverted gear trains, or different types of gear trains. In case of epicyclic gear trains, the axis of shafts on which the gears are mounted may be related to a fixed axis. So epicyclic is the one which is inside, it is rotating one more gear. And this is normal gear train, where it is a series, a connected getting series. If I drive, if A is rotated, then it makes the idle gear to rotate another one. Again, it is getting to the final thing. The thing is, will get the speed, different speeds and directions will be different according to the number of idle gears and number of teeth. So in this compound gear trains, we can see two wheels are mounted in a same shaft. So that A is a driver here, and final D is the output. So A transfer this speed to B, and B and C are in a same shaft. So the speed will be the same here, and the C is going to give the speed to the D. So we will get it, the speed will be the different. So depend upon the shape and size, the number of teeth, it may vary, the speeds may get vary. And the combinations of the compound gear trains also, it will be helpful. So this is how a gear train will work, and we can change the gears in between to change the speed of the gears. So speed the shaft output, what I want to know. So rotate to linear, we can have a rotary to linear mechanism, that is a rack and pinion. Also it is rotation is converted into linear. And the ratchet pawl mechanism, which is used to make one directional rotation, it is limited to one direction. So when there is a pull or push direction is needed, there we can use this ratchet pawl mechanism. So when heavy load we are lifting, no, when it is getting loading up, suddenly if you leave the lever also, it should not get fall, no. So for that purpose, the pawl is the attachment which is locking the system. It locks the opposite rotation. So only one direction only it will allow to move the load. This is very important mechanism, where you can see this location of this pawl and ratchet. So this ratchet is one which is having a number of external teeth in the circumference, and it is rotating, having an inclined teeth. So it rotates in one direction. Opposite, when it tries to rotate, the pawl is locking this because of the spring action. Already the spring action of this, it will have a clear contact with this. So this is the ratchet pawl mechanisms we have seen. So cams and gear trains and ratchet pawl we have seen. Next we will see about the belt and chain drives.